Hello, everybody. Welcome to Taiwan. This is the Lab Safety Training class. My name is Man Kit Leung. In this class, I would like to introduce you the risks in the laboratory and share the experience with you about how to keep you safe. Is your laboratory safe? It is a good question. Sometimes we will ignore all kinds of risks and believe that our laboratory is safe. However, all of the evidence telling us accidents may occur from time to time. Many chemicals we handle every day seems not to be that risky. However, think about it just like dichloromethane. If one drop of dichloromethane getting into your fingers, the consequence will be really awful. You can see that the chemicals, once they get into your body, they start to destroy your tissues. And turns out you have to have a surgery to cut off all the bad tissues. And after 5 days, you can see the scars here, like that. Even after 1 year, you can still see the damage here. So you can understand how dangerous it can be. Another example is an electric shock. We use electricity every day. We just think that it's supposed to be safe. But in the lab environment, it may not be the case. For example, an electric shock occurred to a 43-year-old researcher this year in the National Research Institute. Luckily, he was safe after being sent to the hospital. The lab safety is not based on the purpose of your research. I borrowed this cartoon from green chemistry. Although your research purpose aims at green chemistry, however, during the research process, we are still keep doing something unknown, and also we are working on unknown science. A lot of unexpected reactions may occur during this process, so we are supposed to have personal protective equipment at all times in a laboratory. If you attend a laboratory without appropriate personal protective equipment, including goggles, lab coat, and gloves, it can be risky. Although you may think that I over-exaggerate the severity of lab accidents, here I would like to show you some data and hope I can change your mind. Following is the list of serious accidents in United States, causing many students injuries or maybe even lost their life. Furthermore, you can find more information about lab accidents through network search. For example, there is a website called Memorial War. Here is the name list of researchers who died in research accidents during the past 5 years. Most of them died in exposures or virus infections. Lab accidents on campus are not uncommon. Analysis of statistical data between 2011 and 2016 of lab accidents reveals that fire accidents are the major accidents to concern. Almost 1/4 of accidents are related to fire accidents. On the other hand, about 30% of accidents originates from uncontrollable mechanical force and high and low temperature. Besides, 13% of accidents are chemical hazards. 6% of them are explosion, and about 5% are electrical shocks. All this indicated that fire accidents, uncontrollable mechanical force hurts, chemical hazards, explosions, and electrical shocks are the major reasons of lab accidents. So today I would like to deliver several major concepts about lab safety. First of all, I would like to convince you research labs are potentially dangerous work environment. The second point I would like to convince you to create and understand safety culture, just simply because it is very important to your safety. Think about that safety education has to be broad-based. Only small groups of professional people understand safety issues is not enough to secure safety. Why? Because if one ignorant people cause accidents, you may be the victim. There are several guidelines in the laboratories. For example, first, don't work alone. Secondly, don't try to scale up any reactions or energy arbitrarily. The third one indeed is please check all precautions before you decided to do an experiment. And you're supposed to follow standard operating procedures at any time. Finally, I would like to remind you to protect yourself by taking personal protection equipment. You should keep all the emergency phone number in mind so as to call for help. Safety is as simple as ABC, which is always be careful. Here comes up to a short summary of the first section. Understanding risk and hazards and knowing the way of controlling the risk and hazards is job 1. Your destiny depends on whether you can handle the accident, just like handling a chained dinosaur. If you are careless, the chained dinosaur might hurt you or even kill you. In the following materials, we are going to share with you about the experience on campus safety, fire accidents and emergency response, laws, codes and regulations, laboratory general safety guidelines, precautions and regular inspections before, during, and after experiments, standard operating procedures, personal protection, lab management, safety of chemical storage and handling, electrical hazards, mechanical hazards, and high-pressure vessel, and waste management. Hopefully, these kinds of the knowledge may help you to keep you safe. Campus safety. The second section is about campus safety. According to the statistics, almost 1/4 of the lab accidents are related to fire accidents. So first of all, let us understand how to deal with fire accidents. In case of emergency in NTUST, don't be panicked. You should learn how to call for help. Although you may think that you cannot speak Chinese, it doesn't matter. You can simply directly call our fire department and ambulance through 119, or calling for police and rescue through 110. Once you get the lines on, don't hang them up arbitrarily. You should provide all kinds of information to the rescue team so they can assess you appropriately. First of all, please let them know where you are and what's happened to you. Are you getting hurt? Do you need ambulance? Not until they say you can hang up the phone. Please keep yourself online. After calling for help outside, you should contact our university security. Once the rescue team reach the front gate, our university security will guide them to the place where you are. It is very important because the rescue team outside may not know the campus as clearly as our university security. Here are some numbers you should dial in your mobile phone. Please keep them in your phone. In case of emergency, you can call for help. Also, finally, you should let your professor or director know the situations, in particular in case of fire accidents. Well, because the fire rescue team needs to know your laboratory environment before they can make decisions on the tactics about how they rescue you. In case of escaping from fire accidents, Several things you have to keep in mind in advance. First, be familiar with your evacuation plan. When you walk into any buildings, there will be a map like that, so-called the fire evacuation plan. In that map, all the emergency exits will be clearly shown. And then you should follow the directions to leave the building as soon as possible once you hear the fire alarm. The second thing you should pay attention to is to join fire drills. Don't try to run away from any fire drill because it provides you the chance to know the escape routes from the building. Finally, never ignore any fire alarms or warning. Don't think that they are not real. So once you hear the fire alarm, leave the building immediately. Fire accidents can occur anytime on campus. Here is one of the examples in 2014. A fire accident occurred on a scientific research building. Fire growth develops quickly and can become out of control within 5 minutes. When a sofa catches fire, the fires developed within 5 minutes to become a disaster, which means that you have limited time on response. So that's the reason why you have to equip your laboratory with portable fire extinguisher. At the very beginning of a fire accident, you may still have good chance to put out the fire promptly. Try to use your fire extinguisher to suppress the fire, or you can use fire sand or blankets to cover the fire in order to isolate it from air. Following is the YouTube files from NIST about the stage of fire growth.
The life of a deadly fire has begun. This scenario occurs in millions of homes every year around the world.
Okay, we have flames just coming up the back of the sofa. Might be from a cigarette that was left there for a few hours, or a little kid playing with a lighter and giving it a little ignition.
At this stage, the small flame is relatively harmless. To grow, the main source of fuel is the sofa. As it burns, the heat it produces decomposes chemicals in its wood and synthetic material. Rising is a complex concoction of flammable gases. They combine with oxygen in the room to produce a dazzling chemical reaction: flames. As the flames radiate heat downward onto the sofa, more and more fuel is consumed. As this deadly cycle repeats itself, the fire grows with frightening speed.
Okay, we had 2 smoke detectors in the hallway that were getting activated. Now the fires began to spread up the wall. You can start seeing heavier smoke building up against the ceiling. That's hot gas that's trapped there by the ceiling.
Experiments like this have led scientists to a simple but alarming discovery. Fires are changing. 107 seconds into the burn, this fire is much hotter than it would have been 20 years ago. The reason? Modern furnishings ignite more easily and burn faster than traditional products like wool and timber.
We can see the radiation from the fire just on the sofa starting to affect other objects in the room.
300 is the ceiling level.
They're smoking, they're pyrolyzing, they're giving off additional fuel. That's additional fuel that's going up into that hot layer that's going to burn.
400 ceiling, 205 foot.
In the 1950s, the average apartment fire took more than 15 minutes to peak at around 1400 degrees Fahrenheit. Today, they can hit a staggering 2,000 degrees. In a little over 150 seconds, this test fire grew from a harmless flame to a raging inferno. The heat and energy it released destroyed the apartment in less than 3 minutes.
In case of fire accident, you may have pretty good chance to suppress the fire by using fire extinguisher at the early stage of the fire accident. So first of all, you have to learn how to use the fire extinguisher appropriately. There are 4 steps of using the extinguisher. First, pull, and then aim, and squeeze, and then sweep. Following is the instruction of using fire extinguisher. Let us see the video.
Instruction on how to use the fire extinguisher. The acronym are pull, aim, squeeze, sweep. Before using the fire extinguisher, inspect the pressure gauge first. The arrow should be at the green shaded area. After taking the fire extinguisher, it must be spray tested first before going near the fire source to put out the fire. Pull out the pin. Pull out the safety pin. Turn the seal and pull out the pin. Aim. Pull out the hose and aim at the base of the fire. Squeeze. Squeeze hard the trigger. Sweep. Aim at the base of the fire and sweep the hose left and right. After extinguish the fire, water the embers to cool it down. Let us repeat them one more time. Pull, aim, squeeze, sweep. Pull out the pin. Aim at the base of the fire, squeeze the trigger, sweep left and right, fight the fire.
When the fire is out of control, evacuation immediately. First, raise your voice and cry loudly for help to raise attention. Evacuate the laboratory. Shut the power off if possible. Close the door to contain the fire and smoke inside the laboratory. However, please don't lock the door. Press the fire alarm to warn the whole building. Evacuate to a safe place. Dial 119 to call the fire station for help. Call your university security. They will guide the firemen to the scene of the accident. Finally, call your professor. Something that you have to pay attention to for evacuation: don't take elevator. Approaching the nearest exit. Take the safest route with the least amount of smoke and heat. Closing doors on your way out. Once escaped, report immediately to safety officer. If in case you need to escape under toxic smoke, getting lower and going under the smoke to your exit. In case you get trapped, sealing yourself in a safe place. Contact the fire department about your location. Use anything to seal the door cracks and cover air vents to stop smoke from coming in. If possible, open your windows to allow fresh air getting in. Laws, codes, and regulations. There are many laws, codes, and regulations about lab safety behind. However, those regulations are very basic requirements for your safety. The first act that you need to know indeed is Occupational Safety and Health Act that links your employer or your professor to you. The purpose of Occupational Safety and Health Act is to prevent work and health hazards to workers. For employers, they're supposed to provide safety and health facilities. Also, they need to formulate, announce, and execute a safe and health management plans. On the employee side, you're supposed to receive the safety training and follow the safety regulations, and also do the health check. Violations for all those things will cause a violation fine for $3,000. Besides the Occupational Safety and Health Act, there are many other laws, codes, and regulations around you that link you to the society. Of course, I know that you may not be able to understand them all. However, never hesitate to ask. There are many laws, codes, and regulations that link you to the environment. For example, you are not allowed to do anything causing public danger. You are not allowed to pollute water and air. You are not allowed to create noise and also dumping waste outside to pollute the environment. When you need to use dangerous chemicals, you have to follow the guidelines of dangerous chemical control regulations. Behavior or crimes against public safety include setting fire, causing flooding, using any explosive without license, releasing nuclear energy or radioactivity, using radiation without a justified reason, and causes damage to another's body or health, throwing, abandoning, drowning, or releasing poisonous substance or any other harmful things to pollute air, soil, river, or other bodies of water. Those are crimes against public safety. When you decided to work into the laboratory, you have to take some professional training in advance. First, you need to take a 3 hours training on general laboratory safety. If you need to use chemicals, you need to receive another 3 hours of training on educational training on hazard communications. When you need to get in touch with bioinfectious materials, or you need to do genetic recombination experiment, you need to receive 8 hours of training before, and then for continuation education for 4 hours every year after. If you need to use radiative materials or machines that can create radiations, then you need to receive radiation protection training for 3 hours. If you need to reorganize the electricity in your laboratory, you need to receive electrical safety training before. Of course, I know that the law system might be too complicated for you, and maybe you will be unable to understand and comply with all the laws without assistance and consultations. The role of Office of Environment and Safety is to link you and bridge you to the law. If you have anything that you don't understand, never hesitate to dial the number and contact our Office of Environment and Safety for help. Safety guidelines. You are supposed to try hard to make every effort to avoid accidents. How can you do that? First, you are supposed to look for safety precautions and receive related trainings. And then you have to communicate and discuss with your professor until you can understand the experimental details clearly. It is your responsibility to check references and write down notes about the experiment. You have to take care about the maintenance and repairing of the machines. Make sure that you have prepared the records for all the maintenance. Also, you have to follow the safety guidelines and also standard operating procedures when you need to use those instruments or doing experiments. You are also supposed to make arrangements in place to deal with accidents. For example, fire extinguisher, fire sand, fire blanket, or spill kits in case of chemical spills. The next one to remind is don't scale up. Here's a slogan from American Chemical Society: less is better. What's the difference between an accident or disaster? It is a matter of scale. Human being knows how to make fire, dated back to 10,000 years ago before the New Stone Age. Fire can generate heat at night. It can be good or bad. It all depends on the scale. For example, the campfire is totally under control. The scale is small so that you can enjoy the campfire, so it is good. However, if the fire becomes totally out of control and the scale is large, just like forest fire, it will become your nightmare. Total risk is a function of severity and probability. For example, the estimated total damage each year in accidents is equal to the number of people potentially hurt or killed in each accident times the occurrence frequency. Clearly, we can see that reduce the severity in each accident is the most important job to do. How can we do that? Reduce the reaction scales is the most effective ways to prevent severe accidents to occur. On the other hand, in order to reduce the probability of human errors, following the standard operating procedure and guideline is the most effective ways to reduce the human errors. Following is the accident on Miss Sanji. At that time, she was a 23-year-old research assistant in a laboratory. She has experience for 3 months. One day she needed to use tertiary butyl lithium for the reactions. Unfortunately, the chemical caught fire and ignited her gloves and the sweater, causing second-degree burns on her arms and third-degree burns on her hands and total of about 40% of her body. She died in the hospital a few days later. What's happened in the accidents? Usually, there are 7 most common causes of workplace accidents. The first one is taking shortcuts. Ms. Sanji decided to scale up the reaction and try to make 3 times of materials at once. She was overconfident, so she decided to carry out the experiment during the university holiday shutdown. So at that day, not many people's work stood around. The housekeeping was poor. There was an open flask of hexane in the hood. During the accident, the bottle of hexane was knocked down, causing the second fire accident, which becomes totally uncontrollable. Ms. Sanji did not follow the standard operating procedure for personal protection equipment. On that day, she did not wear lab coat. After catching fire on her body, Ms. Sanji did not use the emergency shower to put out the fire. And on the other hand, she ran down the hallway and called for help. After looking back the experimental procedure, the investigator discovered that she was lack of preparation that day. She just had a 60 milliliter of syringe, which means that she needs to pull out the chemicals for many times, which is dangerous. If Ms. Sanji could eliminate some of the mistakes, she might save her life. Another accident occurred in Texas Tech University. A graduate student wanted to prepare a derivative of nickel hydrazine perchlorate. When the nickel hydrazine perchlorate was pressed and ground, the compounds detonate. The student lost 3 fingers. The most critical thing indeed is there is a limit of 100 milligrams of that materials in the laboratory. The investigator discovered that the student had no formal training with the material. However, they had near-misses experience before. During the experiment, the student did not wear personal protection equipment and also no shield on the bench top. In addition, the student ignored the use limit and scaled up the reaction to 10 grams. Another scenario about an explosion in a chemistry lab at the University of Minnesota. A graduate student ignored the limit of 5 grams set by a professor. He was making trimethyl silyl azide starting with 200 grams of sodium azide, during the course of which explosion occurred that destroyed the whole film hood. The incident originated definitely in lack of hazard awareness, and also scaling up the reactions to 200 grams amplified the damage. Next important guideline is don't work alone. Next accident was about Miss Michelle Duval, a 22-year-old senior undergraduate science student majoring in astronomy and physics. She needed to make use of the fast-spinning lathe to make a small parts for her experiment. She decided to work alone at night in the machine shops. Unfortunately, the machine's rotating drive dragged her hair and also killed her on the machines. If she did not work alone when the accident happened, her labmate might be able to rescue her immediately. Furthermore, she could not save herself due to the lack of the emergency brake around. Another similar case of hair getting caught in lathe happened in an evening class in an industrial senior high school in Taiwan. Fortunately, the instructor stopped the machine immediately and have his students saved. All this suggested that don't work alone in the laboratory. Next point to discuss is check all the cautions. Don't ignore any abnormal observations during the experiment. It may be the hint about the risk. Thea was a postdoctoral research associate in University of Hawaii. Her research work was to raise bacteria for biofuel and bioplastic production. She needed to prepare a mixed gases of hydrogen, oxygen, and carbon dioxide in a tank. She needed to prime the gas into the reactor as food for bacteria. There was a pressure gauge installed on the tank to monitor the pressure of the gases inside. When Thea pressed the button on the panel, the electrical static caused explosions and destroyed the laboratory. As shown in the picture, you can see the ceiling of the laboratory fell down, blocking up the exit. Thea was unable to escape from the laboratory, and she lost her arm. Luckily, other graduate students and securities outside was successfully pushed the door open and saved her from the laboratory. Here you can see is the tank after the explosion. In this, she had near-miss experience before the serious accident. She had discussed with his professor. Unfortunately, his professor believed that it should be no problem. Try your best to understand all the potential hazards and look up all information from all kinds of resources. Don't just simply rely on the articles in general. Articles in general seldom mention safety information. For example, according to the statistics, about 11 hazardous compounds, they have been mentioned 107 times in journals, but only one article provides cautionary information, which means that you won't get any enough information about the hazards of chemicals from journals articles. Virtually identical incidents occurred at the same institutions within 10 to 15 years, resulting in the destruction or temporary closure of the buildings. Don't think that teaching laboratory will be more safe. You may have chance to become a teaching assistant in teaching lab. However, according to the statistic, 81% of accidents occurs in teaching labs, and 13% in research labs, and 2% in fabrication room. The purpose of setting up standard operating procedures is to prevent us from careless mistakes. Following is an accident about a student who did not follow the standard operating procedures and attempted to clean a double horizontal safe Foster-type concrete mixer during operation. His left arm was sucked in, causing bone fracture. So please don't ignore the standard operating procedure. Of course, the setup is inappropriate due to the absence of an interlock system between the machine cover and the power supply. Furthermore, the setup of the instrument is inappropriate due to the absence of an emergency brake, so the student was unable to stop the machine by himself. Following is another accident about an explosion in a synthetic organic lab in OSU. A graduate student planned to synthesize an aldehyde through ozonolysis of an alkene. Supposedly, it is a two-step synthetic sequence. First of all, during the ozonolysis, an ozonate intermediate will be generated that should be reduced to an aldehyde and then distilled. However, the student forgot to carry out the second step of reduction and distill directly the ozonate intermediate, causing explosion when the temperature reached 50 degrees Celsius. Therefore, pay attention to this. Misunderstanding the operating procedure can sometimes cause very serious results. Fortunately, in the present case, the student has worn safety glasses, which save his eyes. The last chapter is protect yourself. Personal protection is the last line for you to defend yourself. If you have long hair, tie, or bulky clothing, please tie them up or take them off. Long hair, tie, and bulky clothing can accidentally fall into flames or chemicals. On the other hand, long hair, tie, and bulky clothing can be caused in the machine's rotating drive. We have discussed this point before. So when you have long hair must be pulled back and properly restrained. Tie and bulky clothing should be taken off. Generally speaking, shoes for lab work should be able to fully cover your feet. Closed-toe and heel shoes are required usually for lab work. Shoe materials should be non-absorbent such as leather, so as to prevent chemicals from penetrating the materials and getting into your body. Some shoes like sandals, slippers, or maybe shoes with ventilation should be avoided. Safety shoes incorporating steel tool caps are appropriate for working in machine shops. This type of shoes can protect your feet from hurting by sharps. Lab coats are supposed to be able to cover your whole body. Long pants and skirts are highly designed for lab work. Lab coats should be button-front coats so that they can be taken off easily if in case of accidents. Remember that don't take your lab coats back home and use your home washing machines, or dump them to the public washing machines in order to avoid contamination. Sweatshirts are inappropriate for lab work because once if they are contaminated or catching fire, they are difficult to be taken off. Safety goggles are very important tools to protect your eyes from being hurt in an accident. When you work in a working area with subjects that has potential to hurt your eyes, goggle is necessary. Working place such as wood and metal shops or glass shops with airborne abrasive materials from cutting, grinding, and carving, you need to wear goggles. Working place with high temperature facilities such as furnace, cast molding, welding, laser cutting, and other operations generate high temperature, you need to have goggles. Working place with high pressure system or projectile, you need to have goggles. And working in chemical labs, you need goggles. Safety guards must have top and side shields and should be strong enough to resist impact by flying objects. Safety goggles for chemical labs should have a soft, pliable flange that seals around the eyes tightly to protect the eyes from a variety of hazards and chemical splash. Face shield is required for handling low-temperature liquid, like liquid nitrogen, or corrosive liquid, like concentrated sulfuric acid. Remember that face shield only is not good enough to protect your eyes. So when you use face shields, you have also to wear goggles at the same time. A safety mask can prevent dirt, dust, fumes, vapors, gas, contaminant, and any airborne droplets, or maybe bacteria from entering your body. When you need to decide to use masks, you have to aware that different kinds of masks will have different kinds of function. For example, simple surgical mask is good enough for dirt and dust. When you need to have safety masks to filter out fumes, vapors, and gas, you need to have the mask equipped with particular filter to filter off these kinds of the materials. When you use safety masks, the tightness of the seal is the critical factors determining whether a mask will be effective or not. Please test the mask and monitor the results of fit tests and adjust in time before use. Safety gloves is only kinds of membrane that can help to delay the chemicals permeation. Please don't think that gloves can block off any chemicals permanently. Professor Victor Han died of dimethylmercury poisoning due to the fact that dimethylmercury can penetrate the latex gloves within 15 seconds and getting into her body. So when you use gloves, please aware that different kinds of gloves will have different kinds of function. First, if you use latex gloves, your latex gloves should be disposed after use. When you take off the gloves, you should follow the guideline below to avoid direct touching with the skin. First, you take off the gloves from one hand, and then use your fingers to take off the others and throw the gloves away. After that, you have to wash your hand carefully. When you need to use highly corrosive materials or toxic materials, you should select chemical-resistant gloves. There are many different kinds of the materials for the gloves. Please look at the instruction and see which one will be appropriate. Sometimes for the sake of convenience, you may decide to use the thinner gloves. Under that situations, I would suggest you to use 2 layers of gloves. The first layer indeed is the PE gloves, and the other may be the surgical gloves or the nitrile gloves. After learning the importance of the personal protective equipment, Let us explore some accident cases. Through the case study and analysis, we will understand the consequence in case of accidents if there is no protection of the personal protective equipment. One accident of explosion during recrystallization has been reported several years ago in year 2013. The accident occurred in a research lab in an university in Taichung. 2 students were injured. One student has his right eye injured seriously. The student did not put on personal protective equipment, including lab coats and goggles. Furthermore, there was no shield on the bench top to protect the student. Another explosion occurred in year 2015. Explosion of a pressurized carbon dioxide chamber occurred in a civil engineering lab in a university in Taipei. The student carried out a study on the carbon dioxide absorption effect on the strength of concrete. After putting the sample into the chamber was pressurized. Suddenly, the glass window of the chamber was fractured. Shattered glass cuts the student's chest, elbows, and eyebrows. This accident caused a lot of attention. Inspectors from many departments came to the university for inspection. The third case is about sulfuric acid splash in a teaching lab. After finishing the experiment, a student poured concentrated sulfuric acid into a water sink, causing splash of the acid. 6 students around were injured, and 1 student's right eye was injured. The last case is about splashing of molten salt into the eyes of a female graduate student, causing serious injury. Molten salt is a high-temperature liquid. It is a very dangerous thing. Molten salt splashed when the student inserted the material into the bath. Her face and eyes suffered second-degree burn and she lost her eyesight. The reason why the molten salt splashed is unknown, probably because the material is not dry. The water vapors make the molten salt splash. In a short summary, before you start your experiment, you should learn how to protect yourself appropriately. Laboratory environment is not safe. Fire accident, electric shock, explosion, and chemical splash are the most dangerous things. Personal protective equipment is the last defense line for you to protect yourself.